to be explaining our project, Backpropagation Explainer, a geometric visualization for training feed-forward neural networks. So motivated by our discussion with Professor Ruzbani and other machine learning instructors, we understood the need for a better way to explain the backpropagation algorithm. Most current visualizations give a very high-level explanation or an obscene amount of math. We want to do something in the middle that creates an interactive visualization for backpropagation. We use the minced data set to explain the algorithm geometrically with formulas and the math worked out recursively. Specifically, the visualization allows users to click on edges to see how the gradients are calculated across the network and how everything works together. Users can delve deeper and see how each subsequent gradient is computed. Specifically, looking at the approaches, the visualization initially displays a neural network where the user can hover and click an edge. The weight of that edge is highlighted as well as the edges in the layer to the front of it, as shown in figure 4. At the same time, the gradient decomposition formula pops up on the right, and the users can examine and understand both the local and upstream gradient. By clicking the upstream gradient, the recursive nature of the project is in motion. Our approach to visualizing this process differs significantly from existing methods as we focus on the mechanics of backpropagations and how backpropagation works, rather than to show the lifetime training of a network. Through our recursive visualizations, users have a high level of interactivity to explore every path and really understand the nooks and crannies of a network. The impact of our project is significant, and we hope to continue this to really make it a tool for machine learning instructors nationwide. And now for a quick demo of our project. If you go over here, you can see that, as we mentioned, you can hover and click a node or weight, and you can see how this contributes to all the outputs at the end and how the outputs flow back to this node. You can see both how the value is calculated and the gradient decomposition, and you can go ahead and recursively click the upstream gradient, enabling the page to automatically scroll and showing both the math and the gradient and the formulas behind the logic here. And if you click on the local gradient, once you come to a point where there's nothing more to expand, you can see that we come to a stopping condition as such. Here you can see that the specific drop-down values are bolded, and you can double click to remove the visualization here.